Hi guys, welcome to the second video of lesson 9. And I just have some questions here on the screen for you to think about when you're looking at your fraction problems. Have I solved a problem like this before? How is this problem like other problems? So you're going to just look at the numbers and think about what you know. And then while you're working on it, is the strategy I'm using working? Is there anything I could do differently? And then when you're finished, did it work? Do I need to go back and redo it a different way? And what can I do differently next time? Okay, so just thinking about those things as you're doing your work. And we are now on number 2 on page 77. And we have 8/9 plus 7/6. And they are not like, are they? They are not like at all. So think about that. Have you done something like this before? All right. Maybe you want to draw area models, right? Maybe you want to list multiples and think about this problem. So let's do some multiple listing. 9 and 6. I can't multiply 9 by something to get 6. I can't multiply 6 times something to get 9. So let's think about 9s. 9 times 1 is 9. 9 times 2 is 18. Okay, now I've been talking about multiplication facts for a long time. If you know your multiplication facts, then you might already be thinking about your sixes, because 6 times 1 is 6, 6 times 2 is 12, and 6 times 3 is 18. So that's where knowing your facts really helps, because then you're already thinking ahead to these least common multiples, and you don't have to keep going on and on with your 9s and on with your 6s before you realize that you can change them both to 18. Okay, and I think that this is an efficient way of doing things, listing the multiples, writing them down. So let's sort of adopt that as our way of solving unrelated unlike fractions, right? So we have 8/9. Now, what does this tell us? This tells us that we're changing it to 18, right? We're going to change them both to 18 because they can both be changed to 18, right? Then we can set it up like this. We can say 9 times something is going to be 18, and 9 times 2 is 18. And if you didn't know that, when you list your multiples, this is 9 times 1 and this is 9 times 2. So it's your second multiple, so it's going to be 9 times 2. And we always do the same to the top and the bottom, and 8 times 2 is 16. So then we're going to do the same thing to our sixths. 7/6 times something is going to equal 18, right? 6 times what is 18? You can see here it's your third multiple. So it's 6 times 3. And then 7 times 3 is 21. So now we have 16 plus 21 eighteenths. Let's just write it down like this. Make sure we get our math correct. We don't want to do all this hard work and then make a mistake in our addition. 6 plus 1 is 7. 2 plus 1 is 3. That's 37 eighteenths. All right. And for now, you can leave it that way. In the next section, section C, we're going to be looking more in our improper fractions and mixed numbers. But if you did want to, you could drop the 37 into the division problem and divide it by 18. I happen to know that 18 times 2 is 36, because I worked at a school where there was 18 in every class, and 2 classes would be 36. Whoops, and I almost wrote a addition sign there. That should be a subtraction sign, and that would leave 1. So 37 eighteenths is the same as 2 and 1 eighteenths. Okay, very good. If you don't have this all written down on your paper, please pause me and get it written down, because I am going to move on to number 3. All right, so number 3, is 4/5 minus 2/7. We've got to make sure that we make a note of the sign there because we don't want to do all this hard work and then add instead of subtract. 4/5 and 2/7. So fifths and sevenths. Can't multiply 5 times something and get 7. Can't multiply 7 times something and get 5. Can't divide 7 by something and get 5. No, won't work. So let's list our multiples, right? And multiples of 5 are pretty easy. 5, 10, 15, 20. 25. I'm thinking about sevens. Maybe we should list our sevens and see if any of them end in a 5 or a 0, because multiples of 5 end in a 5 or a 0. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 30. 7 times 5. 35, there we go. And I don't even need to do the rest of those because I know that the only one I have is going to be 35. So sometimes it does work that your smallest one is going to be multiplying them by each other. But it helps to list them out because, like I said, you don't want your numbers to get so big. Now remember, the next step is to change both of them so that their denominator is 35, right? So I'm going to say 5 times what is 35? 5 times 7. 7 times 4 is 28. Now I'm going to change my 2/7, have to change them both so that they have a common denominator so I can subtract. And 7 times what is 35? 7 times 5 is 35. And 2 times 5 is 10. Now remember that I'm subtracting. So 28 minus 10 is 18. 18 35ths. All right. And my top number is smaller than my bottom number, so I can leave it like that. Make sure you have this all written on your page for your notes for page 77. Do you want to draw an area model to show this? You can do that, but make sure you at least have this on your page. Area model, breaking it into 35 pieces is going to be a little bit less efficient. All right. So I would recommend, like I said, that we use this method of listing our multiples. All right, thank you very much. I'll see you in the next video. Keep working hard. Aloha.